Hello, everyone, and welcome back to the second lecture of colloidal suspension. And in today's video, we will be covering a couple of topics after we've given an introduction part of what actually a colloidal solution is. And if you haven't watched that video, I think you should go on my channel and watch that and return. So, what we've got here today is a colloidal solution has different names, depending on what kind of dispersed phase it has or even what kind of dispersion medium it has. And we also have some examples here. Basically, when we put colloidal solution in a solid phase and solid dispersion medium, also solid, it is known as solid solution. And you can see if it's solid plus liquid, we call it sol. The examples are given here, and if we put solid and gas, it's called aerosol. Liquid and solid, it's basically called gel. Liquid and liquid, it's emulsion, which example is milk. And liquid and gas, which is again aerosol. The common pattern is that whenever it is seen that it has gas as its dispersion medium, it is mostly called aerosol every time. And again, then we have gas plus solid, which is also solid foam. And the example of it is pumice stone. And we put gas and liquid, it is also foam. I think it's pretty much like things that you really don't need to memorize them, but I think it's just something to keep in mind. Some of them are important if you really want to understand them better. I have given some pictures here as an example. You can take screenshots of those as well. Here are also some of them. I think I've given it inside a chart. It covers everything, so you can learn it from there. And the next topic will be the classification of colloids. Before we go into the classifications, there's a small note here. It is that colloidal solutions are sometimes given specific names depending upon the nature of the dispersion medium, which I've told you before that whenever the dispersion medium is water, it is mostly aquazole, and if it's alcohol, it is alcohol. Benzene names as benzozole, and gas names as aerosol. Aerosol is something that we basically, a lot of us have seen it being used on our day-to-day life, so that's where you can relate to that. And the thing is that another note is that colloid, which is formed by aggregation of small molecules, is called multi-molecular colloids. We'll see that when we study the classifications of colloids. So colloids is basically classified based on two different terms. First classification comes based on nature of interaction between dispersed phase and dispersion medium. That is the number one we have. Well, obviously we'll go into very details into each type, but first we try to understand how we are classifying them. And the second type is based on the type of particles of dispersed phase. It is, and you can see that based on interaction between dispersed phase and dispersion medium, it is classified into two sections. One of them is lyophilic, which is something that attracts liquid or water. And the second type we have here is leophobic, which literally repulses liquid. And the second type of the second type of the second type of classification is basically based on the particles of dispersed phase, and we try to put it into three categories, which is like multimolecular colloids, associated colloids, and macromolecular colloids. After that we'll go very details into them, and I hope you'll then understand them properly. So the first classification based on the particles of dispersion medium. This is based on the particle type of dispersion medium. So basically, the first type that it has is multi-molecular colloids. It is mole molecules, and the colloidal particle are some aggregation. It is mostly formed by the aggregation of small molecules. It has a size of 1 to 100 nanometer. Example would be gold and sulfur. The large Another type we have is macromolecular colloids, which consist of single large molecules. It is very large in size. The difference between these two is that this is very intact and you get the whole size as one, and this is aggregated, broken down. So that's basically the difference between these two. It is also the similar kind of size range. This example of macromolecule are starch solution and gelatin probably. And we have a very interesting type here, associated micellar colloids. It's basically how our surfactant works when we wash our clothes. It is like basically formed by surfactant molecules, which creates a micelle. In this chapter, you will get a detail on how micelle is created. And the example is again soap and detergent, which we basically use during washing of our clothes. So the key difference between lyophilic solution and lyophobic solution is given here. We have told that lyophilic and lyophobic, I think we get these two types depending on the interaction between the dispersed phase and dispersed medium. The interaction between them, depending on the nature of that, we get two types. One of them is lyophilic, another is lyophilic. And lyophilic mainly it is very stable due to solvation, and lyophobic stability comes from electric charge. We'll see how it happens. First, a couple of points is that there is strong affinity between dispersed phase and dispersion medium in lyophilic solution, but in lyophobic solution it is very low. On shaking, you get a colloidal solution from lyophilic just by shaking, but these salts can be prepared by indirect method. It needs some methods to create this lyophobic. You cannot directly turn them into colloidal solution. Here the term salts basically means colloidal solution. I think it is used as a shortcut to every time saying colloidal solution is just a long word. And this kind of colloids are very intrinsic colloid, which means easy to prepare, and these are extrinsic colloid, which is very difficult to prepare. We have seen that by just shaking you prepare these colloids just by shaking, and you cannot literally directly create these colloids. The second type, lyophobic, you have some methods where it is very difficult method to create colloidal solution out of lyophobic salts. So after that, we try to understand what intrinsic and extrinsic means. It is that in intrinsics, the substances which themselves form colloidal particles when dispersed in a suitable medium. They are naturally colloidal, of colloidal size. You don't have to specially treat them. They will automatically directly turn into colloidal solution by just shaking, or no, you don't need any special treatment. But in terms of extrinsic colloids, which is also known as pseudocolloids, what happens is that you directly cannot form colloids from them. These particles are forced into colloidal size by special methods. We'll see how it happens. There's mechanical dispersion, electrical methods, which is Brady's arc method, which is very famous, by the way, and chemical methods as well. By this way, you create extrinsic solution. I mean, it's artificially prepared. The examples here are very clearly given. You can memorize them from here. And after that, uh, the remaining differences between lyophilic solution and lyophobic colloidal solution is that lyophilic solutions, the particles of soul migrate towards anode and cathode in an electric field. In an electric field, it the particles basically ionizes, and the positive goes to the positive side of the battery, and the negative positive goes to sorry for the mistake, the positive goes to the negative side of the battery, and the negative goes to the positive side as opposite attracts. So, but in terms of lyophobic solution, the soul particles may or may not migrate in an electric field. It is not a mandatory characteristics of lyophobic souls. The solids obtained after evaporation may be reconverted to form the soul by simply shaking them. We have studied that before, but you cannot bring this type by simply shaking them. You have to do some artificial methods. These souls are reversible 100%, that means they're stable, and these souls are irreversible. We have seen that here again and again. What reversible meant is that they can be easily converted to colloidal solution just by shaking them. And what irreversible meant that it's not a very natural process to turn them into colloidal solution after that. And the surface tension of the soul is lower than the dispersion medium in lyophilic solution, but the surface tension soul of the soul is the same as the dispersion medium. The viscosity here is higher. The viscosity is basically the same between the soul and the dispersion medium. And here are some very clear example. You can see, you can try to memorize them if you really think it's very important. And after that, we are done with the differences between two type of lyophilic solution and lyophobic solution. If I try to say in one word, lyophilic is something that attracts water, and lyophobic is something that repulses water. So, and what again after that? Well, the three types we have studied that are formed based on the type of the particle of dispersion medium. I told you that there is a type which is associated colloids micellis, which is basically used in surfactants where we wash our clothes. If we try to show you where it is basically this type that we're going to study. I've told you that we're going to study micellis in details after that. So what happens is that a good example of micellis is soap, and we know the 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 chemical composition of soap. It is C17H35 COOH plus Na, which is a static acid. And when we try to put it in an aqueous solution, it breaks into two parts. One of them is anion and another is cation. What happens is that anion forms a chain. It looks like this. You can see, and you can see it has two parts. One of them is tail, which is the carbon hydrogen chain, and the head part, which is obviously a negative part because the H plus was taken out of it. The tail is a hydrocarbon, and hydrocarbons means CH kind of molecules, and hydrocarbon are in nature hydrophobic, and the head part is hydrophilic. Hydrophobic means it attracts water, and hydrophobic means it repulses. water. What happens is that if you get a lot of molecules like that here, and when you shake them, what happens is, suppose if I try to explain it to you here, we have studied, suppose there is water everywhere. We have studied that the water molecule looks like this, and we have also known that this part is hydrocarbon, and hydrocarbon attract, sorry, there was a mistake, a silly one. It doesn't repulses, it attracts and it repulses. The hydrocarbon repulses water. So what happens is that this hydrocarbon part repulses water, and this anion part attracts water. It repulses water. So when you put it inside a water solution, what happens is that due to the repulsion, if we try to mimic it as like this, what happens is that due to the attraction of water towards this part, they position themselves towards the water. If I try to draw it properly, it would be easier for you to understand. You see, the head part is on the outer side and the tail part is inside, because the head part is attracting the water and the tail part is repulsing the water. What happens is that it, if suppose the pink sized particle is a dirt, what happens is that this soap molecules surrounds the dirt like this. There is a much clearer picture. Sorry, sorry for the sketches, I'm really bad at them. You can see in the picture above how the the head part is outside the water, in the layer of the water towards the water, because it attracts the water molecules, and the tail part are, which has a zigzag shape, are inside towards the dirt molecule. What happens, they take the dirt out of any clothes. That's how we clean our clothes. That's how soap works. And this mechanism that we have seen here, and this thing which we have got, the soap molecule, which again looks like this. I'm just writing it repeatedly so that you understand it in a better way. This is the head part and this is the tail part. This is called mycelium, and this mechanism is really important to understand. And after that, we have a detailed note on the three types of colloidal solution that we get when we classify them depending on the types of the particle of the dispersion medium. And we have studied them before, but I have written it here in details. If you really want to study them in a structured way, you can read these things. And after that part, the multimolecular colloids. And here are some other facts about the colloids. The third type, we have studied the third type, which is mycelium associated colloids. The second type is macromolecular colloids. The first type is multimolecular colloids. I'm writing it in a short term. We've studied later. See, multimolecular colloids, macromolecular colloids, associate colloids, which is the mycelium, the water solution that we have got. And if I try to give you a remind you of what I have shown you, this kind of colloid is formed by the aggregation of small molecules or atoms. This is large molecules, and this is mycelium again, what we have studied here, this mechanism. And multimol, we have studied it again, that they are formed by the aggregation of a large number of atoms. And macromolecular solution, a true solution, consists of a single macromolecule so large that they fall into colloidal range.